Hi, I'm Darian and this is your daily question. Today's daily question is going to be question 36 from the 2018 Washington State Math School Masters for 7th and 8th graders. Two intelligent, honest students are sitting together for lunch one day when their math teacher hands them each a card. Your cards each have an integer on them, the teacher tells them. The product of the two numbers is either 12, 15, or 18. The first to correctly guess the number on the other's cards win. The first student looks at her card and says, "I don't know what your number is." The second student looks at her card and says, "I don't know what your number is either." The first student then correctly says, "Now I know your number." What number is on the loser's card? So for those who want to solve this question by themselves, feel free to pause the video. So for those who are able to solve this question by themselves, congratulations, but for those who cannot, here is the solution. First, we need to establish who the loser is, and the loser is the second student, as the first student gets the correct number first. Now to solving the question, we start by finding the factors of each number, as the students' numbers are going to be multiplied to form each number. So 12's factors are 1, 2, 3, 4, 6, and 12. 15's factors are 1, 3, 5, and 15. And 18's factors are 1, 2, 3, 6, 9, and 18. Next, we should find what limits the number of factors. The first student says that she does not know what the second student's number is. Therefore, this first student's number must not be a unique factor. Additionally, this means that with the first student's number, multiplying it with the second student's number makes it possible to get at least two of the three possible numbers, or else the first student would not have needed the second student's number. Likewise, the second student's number also must not be a unique factor. So out of all the factors, which is 1, 2, 3, 4, 5, 6, 9, and 18, we narrow down all the non-unique factors to 1, 2, 3, and 6, as only these factors appear in at least two of the three numbers. From here, it is pretty easy to see that 1 is not an option, as 1 multiplied by any other number in the set does not yield 12, 15, or 18. This leaves 2, 3, and 6. Doing a little testing shows that 6 cannot be the first student's number, and that's because in all two cases, one being the second student having a 2 and the second student having a 3, all allow the second student to deduce the first student's number first. So case 1, or C1, student 2 has a 2. Therefore, student 1 can only have a 3 or 6. Now, student 2 knows that if student 1 had a 3, then multiplying 2 times 3 only gives 6, and that's not enough. So therefore, he can immediately guess that student 1 has a 6. So case 2 is the same thing. Student 2 having a 3, student 1 having a 2 or 6. So if student 1 had a 2, then 3 times 2 is only 6, not enough. So student 2 can also guess that student 1 has a 6. So because both these cases don't work, student 1 cannot have a 6. With 6 losing the possibility of being the first student's number and a combination of 2 and 3 for the students not reaching any of the three numbers, 6 must be the second student's number, and since the question asks for the loser number, our answer is 6. That's all I have for you today. If you liked the video, please like and subscribe, and I'll see you guys next time.